Let us observe those applications. Here, the first application, what we are going to discuss today is they told that three bodies are there. Three bodies are there. One is projected vertically up from the tower. From the tower is vertically projected up. So the height here is h. The height here is h. And the time it took to reach to the ground is t1. And next case, they told that the body is thrown down. The body is thrown down like that with velocity u. So now it is coming down and reach to the ground here. So here, protected vertically down means here u value is equal to u. It's not 0. U value is equal to some value is there. Let me take the value is initial velocity as u. It is coming down and from same height, it is h. And next situation, that is the body is dropped freely from a top of tower, from a top of tower. Freely falling body means here we have to write u is equal to 0 and here the height of the tower is h. So three situations we are taking now. Now in this situation body is freely falling down, So here the time t1 in the first situation, time t2 in the second situation, and they have given here in the time t3 in the last situation, t3. So now how they are t1, t2, t3 are related to each other and how h is connected with t1 and t2, how times are connected to one to each other. The first one is projected vertically up from the tower, projected vertically up from top of tower. Second one, vertically projected down, Third one, freely falling, initial velocity 0. Vertically projected down, initial velocity is u. Here also the body is projected with the same velocity u. In the vertically projected upward from top of the tower, there also velocity is u. And it is a freely falling, here also velocity, vertically projected down, here also velocity is u. And freely falling, velocity is 0. Initial velocity is 0. Body projected from top of tower, time t1. Body projected vertically down and time take 2 to reach the ground. And here t3, in freely falling. Let us observe the each situation now and we'll discuss the formula for that. So in the first situation, that is body projected from top of tower, if you observe, body projected from top of tower. Here we know the formula for when our velocity is u and height is h here. It reaches the maximum height here. So maximum height it reaches is, and again it comes back to ground, again it comes back to the ground. So here what is the formula means here initial velocity of projection is u, a equal to minus g and t is equal to, here I am writing as time t1, and displacement means we have to take minus h. Why minus h, sir? Displacement is always shortest distance between initial to final. Body projected up and displacement is measured down. Initial point, final point, measured down. Down in direction I am taking it as minus. From that information, by constructing the formula, that is by using s equal to ut plus of at square. If you just substitute in this one, what will happen here, beta? Here you can observe s is minus h, ut minus I can write of gt square. So if you send minus, multiply the minus everywhere on LHS and RHS, h is equal to minus ut plus of gt square. But remember here time I am calling it as t1. So I have to place here t1 here. Here also time t1. So this is the expression I got for body projected from top of the tower height value. Similarly, when you observe the vertically projected down here u not equal to 0, u is equal to u and body is projected down and the projected from a height h. So here what happened, u equal to u, a equal to freely falling coming down, not freely falling vertically projected down. It is also acceleration plus g. T equal to now time taken as t2 and displacement. Initially it is projected which direction? Downward. Body is all now we are measuring initial to final also downward. So it is positive. In previous concept, projected up and displacement down. Here projected down, displacement down positive, but in previous projected up, displacement down we have taken negative. So from here, if you substitute simply S is equal to ut plus of at square formula. In this formula, if you substitute, we'll get h is equal to ut2 plus of gt2 square. So it is very comfortable. Here we got the formula. Here h is equal to ut2 plus of gt2 square. So if you observe, let me call this as equation number 2. And previous equation, let me call it as equation number 1. This one I am calling it as equation number 1. So now equation 1 or 2, h is same. From same height they are top. Same height, one is projected up. Same height, one is projected vertically down. As height is same, so LHS are same in equation 1 and 2. So from that information I can write. So from 1 and 2, from equation 1 and equation 2, as LHS are same in the both the situation, I can write minus ut1 plus of gt1 square is equal to ut2 plus of gt2 square. So now what happened here? So let me take here this minus ut1 is there, that side it is there. So if I take minus ut1 other side and of g2 square in this direction, rest I am taking shuffling the terms here. So I can write now of g into t1 square minus t2 square is equal to u into t2 plus t1, I can write like that. And you know from your maths knowledge, that is a square minus b square can be written as a minus b into a plus b. So t1 minus t2 into t1 plus t2. This is the expression what we know from your school knowledge. A square minus b square equal to a minus b into a minus b. So very well known this one. So here u into t2 plus t1. Now can you observe any terms cancelling here? Yes, the terms will be cancelled. What are the terms? This t2 plus t1 is cancelled. So what we are left finally means the initial velocity as u is equal to g by 2 into t2 minus t1. T1 minus t2. We got here t1 minus t2. Check the previous expression, you will understand whether you got that expression or not. That is the previous expression what we have. So here the both are cancelled and we got this expression. So this is the formula for u we got. That is a velocity of projection formula is g by 2 into t2 minus t1. Now as velocity formula we know what is the formula for height. So for height formula you want to find, first of all, here height formula, any one formula you take, h is equal to what we have for vertically projected up means I can write minus ut1 plus of gt1 square. This is the formula from equation 1. But what we came to know that as u equal to g by 2 into t1 minus t2. So we can substitute this expression in the formula of h. So let us substitute here what we are going to get. Let us check it out. Minus u into u means minus g by 2 into t1 minus t2 into t1 plus of gt1 square. This is the expression. So expand these terms. So h is equal to minus g by 2 t1 into t1 square minus of minus plus g by 2 t1 t2 plus of gt1 square of gt1 square. Observe carefully here when I expanded here this term and this term. Both are equal. So these terms are equal means I can cancel. So what I am left with? I am left with g by 2 t1 t2. So now from this expression I got h is equal to g by 2 t1 t2 I got. And in the both the cases, what the velocity means? U is equal to I got g by 2 into t1 minus t2, and h is equal to height of the tower as g by 2 t1 t2. Fine. We discussed till now body projected from top of tower. This is the situation when body is projected from top of the tower with a velocity u, or again body projected vertically down here, down it is projected with a velocity u is equal to u. In the both the cases h is same, height is same. So these are the situations what we got, the velocity value and h value we got like this. Now let us take the third situation, that is freely falling. Freely falling. In freely falling from same height, again freely falling also from same height we are discussing. Height is same h. Here freely falling means a equal to g. So u is equal to 0, a equal to g, and s is equal to coming down and h is height h. So from here we got h, and time here t equal to t3, time t equal to t3. Substituting in the formula, s is equal to ut plus of at square. Here what we can write in this formula, s is equal to what I can write, h, u is equal to 0 plus of gt square. From this formula, I can write freely falling as h equal to of gt square. We know very well about this one. So here we got h equal to half gt square, h equal to half gt square. In previous, what we got, h equal to g by 2 t1 t2. In all the three cases, h is same. In all the three cases, h is same. So what should we write now? Here h equal to g by 2 t1 t2. Here h equal to half g. What is the time here? We are calling it as t3. We have to put it as t3 here. t3. In freely falling case, t3 we are taking. So let me take one fresh page. So now what I proved here is h equal to previous of g t1 t2. Now I got h equal to of g t square t3 square. From these two informations, I can now equate LHS. I can write of g t3 square is equal to of g t1 t2 means is of g, this will be cancel, of g cancel. I'm left with t3 square is equal to t1 t2, or I can also write it as t3 is equal to square root of t1 t2. This is my expression. So we got the relations among all the three cases. What are the three cases we told? At the starting, you can see the diagram. We selected three cases. Here T1, T2, T3. These are the three situations. First situation, vertically projected up. Second situation, vertically projected down. In the first and second situation, initial velocity is same. Here also u, here also u. Projected up and here projected down. In third situation, freely falling body. Here, what are the expressions we got? In these two, what we got? H is equal to in this one. First here, in the both the cases, common thing is initial velocity. In the both the cases, common thing is initial velocity. First from here, what is the h value we got? H value we got it as minus ut1 plus of gt1 square of g t1 square. Here what is the h value we got? In this situation, h value we got minus u, sorry, no minus. Here h value got it as ut2 plus of gt2 square of gt2 square. common formula about u in the both. U equal to G by 2 into T2 minus T1. Combining these two, we got U equal to G by 2 into T2 minus T1. And one more common formula, what we got here, H is equal to half G T1 T2. We can write H equal to half G T1 T2. So from here, from this freely falling, we got H equal to half GT square, half GT square from freely falling situation. So now equating these two situations, finally we wrote how this T are, this is what is the time here. In this situation, time is T3. So finally, H equal to half GT3 square, H equal to half GT1 T2. So we have given relation as T3 is equal to square root of T1, T2. T3 is equal to square root of T1, T2. This is the information what we got from this application. Very important application for competitive examination point of view. So I hope this is clear now. Let us see here. One more important point I want to discuss, one more application. That is, here, we discussed till now about freely falling body, vertically projected body from top of tower, vertically projected downward, like that. So many situations we discussed. Now our target is some interesting points. That is, a body is projected up, and here in last second of upward motion, what is the distance traveled in last second of upward motion and last second of first second of downward motion, last second of upward motion and first second of downward motion relation I want. So here the body total height is, let me take it as h, from here to here the height is h. So in last second, how much it traveled means, let me take it as Hn. I don't know. Last second of upward motion, I'm calling it as Hn. And first second of downward motion means it is H1, I'm taking H1. So here Hn and H1. So body projected with velocity U. So Hn is last second of upward motion. Distance travel, what is Hn? Distance traveled in, distance traveled, I can write it as distance traveled in last second of upward motion, last second of upward motion, last second of upward motion, upward motion. So what is H1? H1 is, that is the first second in downward, first second in freely fall, first second in case of freely fall, in case of freely fall. So first second in case of freely fall is taken as H1 and last second in upward motion is taken as Hn. What's the relation between Hn and H1? That is our target now. Okay, first we'll discuss only upward motion. Here body is projected with velocity u and here velocity is 0. So last second motion is Hn, I told. So last second is nth second. Suppose n is last second. N is what we have taken, total number of seconds. N is total number of seconds. Total number of seconds. And nth second is the last second. Nth second is last second. Nth second will be called as last second. Obviously, last second of the journey. Last second of the journey. So now from here, I know that when the body is going up, time of ascent formula. Already we discussed time of ascent formula. What is time of ascent formula? We know time of ascent is equal to U by G. Here time of ascent is nothing but total number of seconds or n seconds, I told in the upward motion. So time of ascent is nothing but here n. N is equal to U by G. I can write now n is equal to U by G. So I know the formula Hn is equal to When your body is projected up, Hn is equal to u minus g by 2 into 2n minus 1. This is the nth second distance traveled in nth second formula. And in this formula, let us substitute in the place of n u by g. So what should I write? U minus g by 2 into 2 into in the place of n u by g minus 1. Let me take a first page. The last line I'm writing again the first page. Let us check that one. I have written here Hn is equal to u minus g by 2 into 2n. N in the place of what I am writing? U by g minus 1. Expand that. Hn is equal to u minus 2 to cancel, gg cancel, minus u, minus of minus plus g by 2. So what happened here? In last second, the distance traveled is g by 2. Last second of upward motion, distance traveled is g by 2. Now let us check in freely falling. Freely falling, what will happen to the distance traveled in first second of its motion? First second of its motion. That is in first second means h1. So what will happen here? h1 is equal to, what should I write here? h1 is equal to, so generally it is a freely falling body. Freely falling body means I can have the formula simple h equal to half gt square. So yeah, t is equal to first second we told. First second means t is equal to 1. So h is equal to h1 is equal to, now in this formula if you substitute in freely fall, half into g into 1 second. So h1 is also equal to g by 2. H1 is also g by 2. Now I got h1 as g by 2. That is the first second in freely fall. And last second in upward motion also I got g by 2. So from these two informations, what I can conclude? I can conclude these values of hn, that is distance traveled in last second of upward motion and distance traveled in first second of downward motion. Distance traveled here in first second of downward motion. Distance traveled in first second in the case of freely fall. First second in case of freely fall. So these two are now according to here I got h1 is equal to g by 2. This value I got g by 2. hn is g by 2 I got. h1 is also is equal to g by 2. Both are g by 2 I got. So I can write now from this my conclusion is distance traveled in last second of upward motion and distance traveled in first second of downward motion. When a body is projected vertically up, both are equal. I hope you are clear with this application. So in today's class, we discussed two applications. One about the comparison of vertically projected upward, vertically projected downward with same velocity and freely falling. Second application I discussed, when body projected vertically up, the distance traveled in last upward motion and distance traveled in first downward motion, first second in downward and last second upward motion, both are same. So this is the concept related to the free vertically projected upward body. I hope it is clear. Thank you everyone, beta. We'll take the next session and we'll continue few more applications. Thank you very much.